spread out state in the other quantum state. Okay, this is the gist of the uncertainty principle. If something is measured precisely in one operator space, it cannot be measured precisely in the other operator space. It has to be spread out. Okay, that is the gist of the uncertainty principle. And that is only true if two operators are not commuting. And we saw that in some of the proof that Ian tried to do for the position and the momentum operator. We know that P comma X hat is equal to IH bar, right, or something. Is that IH bar or IH? Right? It's something like that. Or minus IH?
This is IH.
IH, right? So the two do not commute. Because they do not commute, they cannot share the same set of eigenfunctions. So if something is very well defined as an eigenstate of P hat, it cannot be a pure eigenstate of X hat. If something is well defined to be a pure eigenstate of X hat, it cannot be a pure eigenstate of P hat. Okay? So if something has a very well defined momentum, it cannot be having a very well defined position. If something has a very well defined position, it cannot have a very well defined momentum. So a particle with a very well defined momentum is this particle with this wave function. Its momentum is h bar k. Its momentum is very well defined. And then you can say that this actually is an eigenstate of so this is the eigenstate of this momentum operator. But yet if you look at this function, okay, its position is completely undefined. Its position is completely undefined. You do not know where this particle is in terms of position. It's spread out all over the place in the position space. So if you look at this function, it's everywhere, right? Everywhere in space. That's what this means. There's the physical meaning of this kind of thing because the two operators do not commute. However, if we define this with a wave function that is maybe that looks something like this. This is completely well defined in position. This function looks like this. The other function. But then if you look at it, it has to be sum of all momentums, as you have learned in your course in signal processing. This has to be written as sum of all momentums. So when it's well defined in position, it is completely undefined in momentum. And that is the gist of the uncertainty principle. So it's a lower level definition, and a higher level reason is this. Okay, this is a higher level reason for what you observe, for this very simple uncertainty principle that you observe in your signal processing course as well. Okay. I guess we'll stop here, and next time maybe we can go into generalized uncertainty principles and so on.